Okay, another factoring challenge. This is not a quadratic, it has four terms, it's a cubic, and the coefficients on it are a little distracting. I'm not a fan of all these fractions here, so let's get those cleared out before we do anything else. If we can get a common denominator for all of these coefficients, then we can factor that denominator out, and that should make this a little easier on the eyes. So for denominators of 15 and 5 and 3, and we can make this a fraction by putting it over 1, our common denominator would be 15. So let's change all these fractions to be over 15. The first one is fine. We can leave that the way it is. For the second one, we will triple the top and bottom. For the next one, we will quintuple the top and bottom. And we'll need 15. If there's a word for multiply by 15, I don't know what it is, so I'm just going to say this. And let's see what our fractions look like after we've done that. That gets us to 1/15 x cubed minus 3/15 x squared plus 5/15 x minus 15/15. Okay, good. What's good about this is that now that these all have a denominator of 15, we can factor out 1/15. That's like dividing the entire thing by 1/15, which is equivalent to multiplying by 15. What it does is it clears out all the denominators. We just get 1x cubed. I don't need that 1 there, I'll just write x cubed. Minus 3x squared plus 5x minus 15. Okay. All these things are technically still over 15 because of the common factor, but this is a lot easier to work with now, so that is good. The thing we normally try if we have an even number of terms like this is common factors, factoring by grouping. And we can take these factors, see if there's any factors that come out of those two terms, see if there's any factors that come out of those two terms, and we're going to hope real hard that a common factor occurs when we do that. So let's see what we can pull out. Here's our 1/15, just sitting there. For x cubed and 3x squared, we can factor out x squared. And when we do, that leaves us with x minus 3. For 5x minus 15, we can factor out a 5. And that leaves us with x minus 3. Excellent. This is what we were hoping would happen. If this had not happened, we would be sunk. We would have to go to the rational zero theorem to try to move this thing forward. But because of this repeated x minus 3, this is a common factor. We can pull that out. And when we do, we get 1/15 x minus 3. And what remains after we've taken that out is, with the x minus 3's gone, we're left with x squared plus 5. That's our remaining factor. Okay, can we go any further with that? 1/15 is just a coefficient, that's fine. This is linear. A sum of squares is not factorable, so that should be the end of the line. That's the best we can do with it. So common denominator, pull the denominator out, and that almost always helps you when you've got an expression with a lot of fractions in the coefficients.